Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have been talking about the derivation of the Jacobian element. So, we have just started talking about the matrix J1, or rather basically the submatrix J1. And then for this submatrix J1, we said that this is the structure because J1 is nothing but del P by del theta, and our P vector is given by P1A, P1B, P1C, and then up to Pna, Pnb, Pnc. Here again, as we said, that we are taking n bus system and there are m generators, and the first generator is taking as the slack, and we are taking theta 1a to be 0, that is our reference angle. And so then therefore theta is equal to, or rather it is also a vector, it has got a size 3n minus 1 cross 1, and its sizes and its elements are theta 1b, theta 1c up to theta nb, theta nc. Having said that, then we said that J1 has got this following structure. So this is the first row, this is the second row, then this is n minus 1th row, this is nth row. So I should say that this is, say this is row 1, row 1. This I would say that this is row 2 of this matrix. This is, I say that this is row 3n minus 1, 3n minus 1, and this is row 3n. Right, and this is column 1, column 2. So this is basically column 1, column 2, and etc. etc. So now we said that our general term is del PIP by del theta JL. So now to do that, so we have to now first we have to write down the expression of PIP and then theta JL. So del PIP, so then we know that PIP, we said that L is equal to A, B, C, J is equal to 1 to N plus M, and then VIP, VJL, YIJPL cos theta IP minus theta JL minus alpha IJPL. So we have already defined all these terms numerous times earlier, so we are not again defining it. Now we said that our general term is del PIP by theta JL. Now it can have four cases. One case is that I is not equal to J and P is not equal to L. Case 2 is that when that I is equal to J, that is for example let's say del P3A and P is equal to L. Case number 3, it could be that I not equal to J and P is equal to L. Say this is I, so I not equal to J and P not equal to L, I equal to J and P is also not equal to L, let's say. Let us keep it like this. And 3 is I is not equal to J and P is equal to L, and 4 is I is equal to J, and P is equal to L. So, in the first two cases P is not equal to L, and in the second two cases P is equal to L. So, what does it mean? For example, case A is, say, for example, so examples of cases, examples, say for examples, one is, let us say, del P 3A by, say, del theta 4B, that is case 1. Then case 2 would be I is equal to J, so del P3A, for example, by del theta 3 I is equal to J, but P is not equal to L, so B. So, here you see I and J both are different, and P and L are also both are different. Here I and J are equal, but P and L, they are not equal. Case 3 would be one case where I is equal to not equal to J. So, del P 3A by del theta 4A. So, here I and J, they are not equal, but P and L, they are equal, and case 4 would be all when all are equal. So, it will be del P 3A by del theta 3A, right. So, these are the typical examples. So, but we have to write down for the general case. Now, to understand the general case, because if we just try to write it down from this and then straight away write down the case, or rather the expressions, so then it will not be apparent. So, let us take an small example, small 2 bus example, and with that we will try to derive. First we will derive the particular case, and from that particular case we will try to derive the general case. So, what is, so I have got just 2 bus system, bus 1, bus 1 and bus 2. Please note, I mean, both of them are 3 bus, let us say 3 phase system. So, between bus 1 and 2 there is one line, and bus 2 has got some load. So, it is a load bus, and bus 1 has got a generator, that is the original. So, what is this case? Original case, n is equal to 2 and m is equal to 1. So, it is basically a 2 bus system in which there is only one generator. Now, following our discussion, this system would be translated into basically a 3 bus system. So, I will have bus 2, bus 1, and then, so this is again original bus 1, this is bus 2, and then again I have one bus 3. So, this is the internal bus. So, bus 3 is actually the internal bus, and we shift the generator here. We shift the generator here because we said that these generator reactance, this one, these generator reactance, they are essentially inductive, we are assuming. So, then therefore, there will be no power loss. So, then therefore, whatever power loss is there, so then therefore, whatever power is being injected here, that also will come here, because in this particular generator impedances there will be no power loss. So, now this is a 3 bus system. So, now in this 3 bus system, what are my unknowns? So, now here in this 3 bus system, so I have got So now if I now try to write down, let us say P2A. Now obviously before writing down the P2A, the Y bus matrix would be 9 cross 9. Let us say this is Z series, and this is Y shunt, this is Y shunt. Please note all of them are 3 cross 3, this is 3 cross 3, this is also 3 cross 3, this is also 3 cross 3, right, and this is also 3 cross 3. So let us say that this is YG. So this is, let us say, ZG. ZG is the generator impedance matrix. So we define YG is equal to ZG inverse, and we also define Y series is equal to Z AC inverse, right, and Y bus matrix would be essentially in this case YG plus YSH plus YSC. So it is YG plus YSH plus YSC, and then between it will be minus YSC, and then this is 0. Please note this 0 is a 3 cross 3 0, right. So that we have, this one would be minus YSC, and at bus 2 it would be YSH plus YSC, YSH plus YSC, and no, between Y, sorry, wrong, this is not 0, this is not 0. Between 1 and 3 it would be minus YG, between 1 and 3 it will be minus YG, and at bus 2, between bus 2 to 1 minus YSC and YSH plus YSC, and between 2 to 3 it is 0. So this is a 3 cross 3 matrix. So this is a 3 cross 3 0. I mean basically this 0 is nothing but is 3 cross 3 null matrix, right. I write that 0 is actually 3 cross 3 null matrix. So 0 is a 3 cross 3 null matrix. Okay, so bus 3 to 1 is minus YG, bus 3 to 2 there is nothing is connected, and bus 3 self is YG, right. So this is the Y bus matrix. Now as each of them is 3 cross 3, so it is basically a 9 cross 9, correct. So because it is a 9 cross 9 matrix, so this one is, so because this is Y bus, so I can write that it is I1 ABC, I2 ABC, I3 ABC, that is equal to Y bus, then it is V1 ABC, V2 ABC, V3 ABC, right. So then therefore I1 ABC, I2 ABC, I3 ABC is equal to, let us say, it would be Y11 ABC, then it would be Y12 ABC, then it would be Y13 ABC, then it would be Y21 ABC, Y22 ABC, Y33 ABC. sorry, y23 ABC, y23 ABC, y23 ABC, then y31 ABC, y32 ABC, y33 ABC. So that would be equal to V1 ABC, V2 ABC, V3 ABC, right. So this is the case. So then by comparing this, I can say that y11 ABC is yg. So as an example, so then therefore as an example I say that y11 ABC is nothing but yg plus ysh plus yac, and y12 ABC is equal to minus yac, y13 ABC is equal to minus yg, right. And then y21 ABC is y21 ABC is equal to minus yg, y22 ABC is equal to ysh plus ysh, ysh plus yac, then y23 ABC is 0, it is a big 0, then y31 ABC is minus yg, then y32 ABC is 0 and y33 ABC is yg, right. So this is the case, and every yij ABC is, and I say that yij ABC is written as y, uh, say this is yij AA, yij AB, yij AC. Of course these are all complex quantities, so because of that we should actually use, we are using some different notation y, okay. So and then this is yij, and please note all these are complex quantities, complex, all are complex. Then yijba, yijbb, yijbc, and yijca, yijcb, yijcc, right. So then therefore here it will be y11 a, so the first row would be y11 aa, y11 ab, y11 ac, then it would be y12 a, y12 ab, y12 ac, then it would be y13 a, y13 ab, y13 ac, right. So then here, so then therefore this entire, so I mean that's how it will go. So then with this, let us try to write down the expression of p, say p2a. So p2a, we will just try to write down this expression. P2a is basically, I know that L is equal to a b c, then j is equal to 1 2 3 because n plus m is 3, and then V2A VJL Y2JAL cos theta 2A minus theta JL minus alpha 2JAL, right? So now let us try to expand. So first what we do is that we because it is a double summation, so we have to keep one fixed and then we have to change one. So let us first say that j is equal to 1 and we change L is equal to ABC. So the first is V2A, j is equal to 1, V1A, then Y21AA, then cosine theta 2A minus theta 1A minus alpha 21AA, right? So this is the case. This is the case j is equal to 1, L is equal to A. Then plus. Now what I do, j is equal to 1, L is equal to B. So j is equal to 1. So V2A, then V1, L is equal to B. Then Y21 AB cosine theta 2A minus theta, j is 1, L is B minus alpha 21 AB, right? So this is the case j is equal to 1, L is equal to B. Then plus now I put j is equal to 1, L is equal to C. So V2A, V1C, Y21 AC cosine theta 2A minus theta 1C minus alpha 21 AC, right? Then I put j is equal to 2, L is equal to A. So V2A, then L is also equal to A. So V2A, j is equal to 2, L is equal to A. Y22AA cosine theta 2A minus theta 2A minus alpha 22AA, right? So this is j is equal to 1, L is equal to C, and this is basically j is equal to 2, L is equal to A, right? Then I have got plus, say, plus V2A, then A, j is equal to 2, L is equal to B, V2B, Y22AB cosine theta 2A minus theta 2B minus alpha 21AB, right? Plus V2A, V2C, Y22AC cosine theta 2a minus theta 2c minus alpha 2 2ac. This is wrong. This is 2. Then v2a, v3a, y23aa cosine theta 2a minus theta 3a minus alpha 23aa, right. So we note that this is for j is equal to 2l is equal to b, and this is equal to j is equal to 2, l is equal to c, right, and this is j is equal to 3, l is equal to a, right. So last two terms are remaining, plus, so plus v2a, v3b, y23ab cosine theta 2a minus theta 3b minus y23ab plus v2a, v3c, y23ac cosine right. So then therefore, so this is basically j is equal to 3, l is equal to b, and the last one is j is equal to 3, l is equal to c. So you see, so now, so I mean this is the basically the composition. So this is the expansion. So first we have taken j is equal to 1, l is equal to a, then j is equal to 1, l is equal to b, j is equal to 1, l is equal to. So first we have finished j is equal to 1 and finished for l is equal to abc. Then you have taken j is equal to 2, then you have finished l is equal to abc. Then you have taken j is equal to 3 and then finished l is equal to abc. So then altogether there are 9 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the expansion for P2A, right. So obviously for an inverse system it is not possible to write down this kind of expression by hand, but neither we have to do it. After we do this derivation, and then we would be able to find out the general formula which can be easily programmed into a computer. So then therefore we will continue with the derivation of the Jacobian elements in the next class. Thank you.